IP protocol is part of the layer TCP IP Internet. It is one of the most important protocols on the Internet because it takes care of the transport of IP datagrams. This is called data packets. On the other hand, it does not take care of the delivery at all. An IP packet is used to transmit a message from one machine to another on a network. This is cut into several pieces and transmitted separately. This package is included in a header. This header packet includes the information needed to route and reconstruct the message. Each host must have a unique address to be able to communicate on an IP network. We have seen that an IP host is a device at the end of the chain. The IP address consists of two parts. There is the network ID, which identifies the network the host is part of, by routers to know where to route packets, and there is the host ID, which identifies the end device. Basically, the network ID is the equivalent of a street, and the host ID is the equivalent of a house on that street. If you order a product online, you give your own address so that the post office knows where to deliver the product. Well, it's the same in a network. IP addresses are used to identify the location of a host on the network. There are two types of IP address. There is IPv4, which is the type of address most used on the Internet, and there are the IPv6 addresses that were designed to solve the IPv4 address exhaustion problem. Let's go back to our IPv4 header. Before you can send an IP packet, you have to add a header to it that will contain all the information necessary for it to reach its destination. Some fields are static, like the version field, and others are changed along the way, like the TTL field. We are now going to see all the fields of a header. The version field simply indicates the version of the protocol. That is either IPv4 or IPv6. The IHL field corresponds to the length of the header. The TOS field allows you to mark a packet as being more important than another. The field TPL describes the length of the packet. It includes the header and the data, which is represented here by the data field. The fragment ID identifies whether the packet has been fragmented. Field flag defines various control indicators concerning fragmentation. Field fragment offset is also related to fragmentation. It indicates where the fragment was made. The TTL field includes the number of routers that the packet can still pass through before being destroyed. This is to prevent a packet from spinning indefinitely in a network, for example because of a routing problem. It can be compared to an expiration date. The field protocol indicates the protocol that is used for the data in the packet. That is to say, what is in the field data. The checksum field is used to check the integrity of the header. If it considers that the packet has been modified in its route, then it will be destroyed. The source address is the IP address of the machine which sent the packet. The destination address is that of the machine for which the packet is intended. The option field includes various optional parameters, which are used very rarely. And the field data corresponds to the packet data.